Okay, so we're looking at example 2 from chapter 7 on the applied book for statistics on hypothesis testing. And before we really get into the maths, which is going to be later on in the topic, we're just going to sort of learn the setup for these questions. So we're given this context about an election candidate believes that she has 40% support from the residents in a particular town. A researcher wants to test this at a 5% significance level for an overestimation. So the researcher thinks that this candidate has overinflated how much support that she has. The researcher then tests 20 people and 3 are in support. Now, what we can't do is just say, well, 3 is less than 40% of 20, so therefore it's nonsense, because we've got to allow for some sample variation. So essentially what we're saying is that, well, it could still be 40%, even if 3 out of those 20, only 3 out of 20 are in support, because we've only tested 20 people. So what we're going to do now is we're going to say, well, what is the probability? If I assume that it's 40% support and I test 20 people, what's the probability that only 3 or maybe fewer would be in support of the candidate? And essentially, if that probability is less than the 5%, then we can say actually that's a really small percentage. So therefore, actually, I think we have overinflated the estimation. But let's have a look at the setup first. So the suitable test statistic, what are we testing? Well, we're testing how many people are in support. So we could say X could be the number of people that are in support of the candidate, and we could say that X, due to what we're doing, could be binomially distributed. We've asked 20 people and we're after this probability here, okay, and this is what we're trying to determine. What are the hypotheses then? Well, my hypothesis, the first one I always write down is my null hypothesis, H0. H0, we go on the assumption that's already there. So this candidate is already saying that we're at 40%. So the null hypothesis, we state that the probability is 0.4. My alternative hypothesis, H1, you have to forgive my pen running out a bit. So H1, we are thinking it's overestimated. So if it's overestimated, actually we believe the probability should be less. It's less than 40%. So less than 0.4. Think about what we just said previously on the recorded video I did. This then makes it a one-tailed test. Okay, so this makes it a one-tailed test because I'm only looking at going less than 0.4. If this person said, I don't believe it's 40%, but I don't know which way it is, then we'd just say not equal to, and it'd be a two-tailed test. But this person's stating, I think this is an overestimation, one-tailed test. The last question, explain a condition under which the null hypothesis would be rejected. So we're now testing this. Is this true or isn't it true? And we're going to go back to what I just said before. If I find that the probability that only 3 people out of 20 are in support of this candidate, if I find the probability of that occurring is less than 5%, then I can say, well, actually, this isn't true. Okay, so we can reject this. So what I'm going to test is this. The probability that X is less than or equal to 3. So what's the probability of 3 or fewer people out of those 20? If, forgive the pen, if this is less than 5%, we can then reject the null hypothesis. Okay, so if the probability that the number of supporters is less than or equal to the 3 that are stated, if that's less than 5%, we can then reject the null hypothesis and we can accept the alternative version. We can now say, actually, it seems that the researcher is right in this. Because if we had 40% support, actually more than 3 people if this is less than 5%. We don't need to do the calculations at the moment, but we will do later in the chapter. So now you should be able to have a go at exercise 7A. Please have a look at the questions I'd like you to do on Show My Homework. Cheers.